Hi everyone. So in this lecture, we're going to see how temporary failures are being handled in a key value store design. So now we have looked into how we detect a failure through gossip protocol. So now we see how we handle those failures. So basically, failure can be of two types, like one is temporary and another is permanent. So in this video, we will look into how we handle temporary failures. Means the node is down for a particular period of time and after that it is automatically up. So as we know, suppose our setup is S0, S1, S2, S3 and we have a put request. Each has its own preference list. So S0, S1, S2. It is a preference list of S0 as we have seen. Q1 value 1. So it puts the request here, it puts the request here in S1 and S2. Suppose S2 is down for a certain period of time and it is not available. If we remember, I have discussed in the earlier videos also this equation R plus W greater than N, or rather this equation is not important, but if you remember what this denote, these are those quorum for R and W. In this case, W is important since we are performing a put request, and if we follow a strict quorum, since S2 is down and if W is 2, then S0 will not respond or not send successful response to client till S2 is down. Thus, system unavailable. Which is a warning situation we have reached. Because we are following strict quorum, W is 2, so we need at least 2 responses for S0 to send a successful request, a successful response to the client. But since S2 is down, we can't get a successful response and thus the system is unavailable. So to handle this scenario, so instead of strict quorum, what we do is another term which we will hear right now is called sloppy quorum. So what happens in this is, instead of enforcing the strict quorum, our system chooses first W healthy servers for writes and first R healthy server for reads. Since we are performing a write operation, we will look into the example through a write perspective or write point of view. So suppose S2 is down and our S0 requires W healthy servers to send a successful request. So for the time being, what it does is sends the write request to S3 till, and S3 handles the write request, handles the write request, sends the acknowledgement to S0, and S1 is performing as it is. It sends the acknowledgement to S0. S0 has 2 acknowledgements and S0 thus sends a successful response to the client. Whenever S2 is up and running, S3 what it does, it updates those data, updates all the data to S2. And now S2 has all the data and the system is performing as it was expected. So what happened when S2 was down and S3 was handling the data? Firstly, our system was available all the time. S3 handles a temporary when S2 down, S2 up, S3 updates S2. So a system was available all the time and there has not been any performance delay or any system unavailability. And this method of S3 handling the request temporarily and then updating S2 whenever it is up, this is called hinted handoff. So in this way, we handle the temporary failure situation when S2 is down for a particular period of time and it automatically is up now, or we make S2 available now by performing some operations or some things to be taken care of before S2 is up, and S3 then updates the data to S2. So we have seen this example for a write request. Similar thing happens for a read request also. And thus a temporary failure situation has been handled successfully.